What is flow? What is flow? You think this would be easy? Um, Flow is a blockchain built by application developers for application development. I think Flow is the only blockchain that was ever built by a team that had written smart contracts before, that had the intention of building applications for regular folks who are more interested in getting stuff done rather than having to deal with a bunch of little details. It's kind of surprising that so many people talk about Web3 coming to a wider audience when most protocols require you to understand asymmetric cryptography in order to even have a chance at interacting with the chain properly and securely. And so Flow was built from the ground up with the idea that if you're targeting a broad consumer audience, there are things that even the protocol has to think about differently in order to make sure that those applications are easy to use, easy to access, and overall just powerful, making sure that you have the ability to do what you want as an application developer without the technology getting in your way, the technology being an enabler for those applications. There are a bunch of protocols that have been built that understand part of the problems of building a consumer application. And I suppose the big ones that people recognized and addressed early on were, throughput, performance, and cost. And those two things are sort of inextricably linked. And obviously, Flow solves those problems and has a really incredibly scalable architecture. But I'm not aware of any other chains that look beyond those, sort of fundamental problems, technology problems, to more human problems, like what does it mean to have an account, and why do I have to have this 128-digit number? Why can't I have why can't I use a smaller number? Why can't I use my phone instead of having to buy a custom hardware wallet? Why can't I just create an application that lets me just log in with my email address and my password when I'm a new user, but when I'm a more sophisticated user, lets me add my own keys, maybe keys from multiple devices to my account, and take over my own assets that way, instead of just sort of it being all or nothing. You're either using Coinbase and everything is custodial and they're managing all your stuff, or you take complete responsibility yourself. There's sort of no middle ground. There's no ability to transition from one side to the other. And in Flow, we thought about all of those questions because as application developers, we needed to answer those questions for our users. And most of these protocols don't give you the tools as an application developer to create those experiences. Flow is designed to be a computing platform first, to be a decentralized computer that anyone can use, everyone can trust, and no one controls, no one can shut it down. And look, there's other chains that have those features, but so much of what you see in the blockchain world is just finance first. And obviously finance is a huge part of what any blockchain can do. And it's amazing that we can build these decentralized systems that can be entrusted to manage, things that look like money. But the reality is that they can be so much more than that. And in order for that to be a reality, we have to take the shackles off and provide additional functionality, additional power to developers and users both. And so, I think the kind of people who should be building on Flow are the kind of people who see bigger things for this technology in the long run. I think that, God, you guys are going to cut this. I think that if all you want a blockchain to do is what blockchains do today, then all the other blockchains are fine. But if you genuinely believe that this technology can do more, then you need a blockchain that is capable of more. And I'll be honest, I don't think there are many out there, and amongst the few that try, I consider Flow by far the most advanced. So at the end of the day, as an application developer, the way that the blockchain does anything for you is in terms of the smart contracts you write and the code programming language in which you express those smart contracts. And having worked on CryptoKitties, having worked on Cheese Wizards, having written ERC 721, it felt like a daily occurrence that I was running into difficulties, limitations, constraints in Solidity. And obviously Solidity allows you to do amazing things. I think that it's incredible that we have software platforms like Ethereum that let you build these sort of autonomous systems that can keep running and keep being available to your users, long after it's been deployed and launched and built. But when we sat down to think about what we wanted out of the blockchain that we were building for our own applications, it was obvious to us that we needed to have something that we should try and aim for something better. And at first we looked at, better syntax, better language constructs, but it didn't seem worth it to just make a language that was a little prettier, but had the same fundamental functionality as Solidity. But man, we found this research out of Carnegie Mellon, and they introduced this notion of resource objects. And it was basically combining the sort of object-oriented programming with linear types, which created this concept that they called a resource, which was just perfect for blockchains. And so once I understood that concept, and the senior engineer working on the sort of programming language problem that we had for Flow, once they were able to explain to me the power of that concept, I just knew we had to have it. I knew that there was just a myriad of problems that we had in Solidity that were just going to fall away by being able to think about things in this new way. And the best way for a non-programmer to understand it is that, as software developers, we express things as data structures, and programming languages intentionally make those data structures very flexible. They make it easy to create those data structures, copy those data structures. When you're done with them, you just forget about them, and they get garbage collected away. And if the only tool you have to represent access control or financial assets or NFTs are that kind of data structure where the language is intentionally trying to make it very easy for you to copy them and create them and whatnot, it's incredibly easy to create bugs where you accidentally duplicate something that shouldn't be duplicated, like a token or an NFT. That you accidentally drop a piece of data that represents value, or you accidentally allow someone to copy a piece of data that lets them access functionality that they're not supposed to. And this idea of a resource, which is a language-defined construct where the language itself, it built right into the guts of the language, it manages the sanctity of those objects, and those objects can be moved around, right? Which is a great analogy for ownership. But they can't be duplicated. They can't be dropped. They can't just be created willy-nilly. They can only be created under very specific circumstances. And when you think about the two primary problems that you're trying to solve in smart contracts, it's how do you manage value, and how do you manage access control? Having that primitive, an object that is unforgeable and uncopyable is a godsend. And so when you apply that idea to smart contracts, a bunch of stuff that, I think most Solidity contracts I've written, about half of the effort has gone into managing access control and, ensuring the sanctity of these objects. And now just the language does it. And when that half of the problem falls away because the language is taking care of it, suddenly you can make the rest of the code twice as complex. And if that extra complexity adds value for the user, adds a more sophisticated application, you've you have the same number of developers, the same amount of maintenance load, but you have twice the functionality for your users, and it's just incredibly powerful. It's funny because you propose building a new programming language, and a lot of people roll their eyes. I mean, I guess if you've never been a software engineer, you don't really realize this, but like, feels like every 25-year-old software developer wants to build their own programming language because, you know, they've got it all figured out. And by the time you're in your 30s, you're like, yeah, usually the answer isn't building a new programming language. And so when we were considering building something net new, you know, I had that skepticism, and it really occurred to me that like we had to defend that decision, at least to ourselves. And the reality is that we do need new programming languages from time to time, and it's when we have new programming paradigms. And so if you go back, you know, in the early days of computers, why did we need the C language? It's because hardware was getting cheap enough that portable software made sense. Instead of writing your software bespoke for every single mainframe computer, you had these mini computers, and you might want to move the software from one to the other, and so you needed a portable language. When databases came out, and we needed SQL in order to construct these queries. And smart contract programming is different. It's not best served by existing languages like JavaScript or Rust. It's not best served by, you know, a slight adaptation of, you know, sort of whatever the current best practices in software development are. We really do have fundamentally different problems that we have to deal with. And of course, that's primarily access control and managing ownership. And so it was, you know, having thought through it using that lens, it was clear that if we had a compelling enough reason, a compelling enough new paradigm, so to speak, that would be enough of a reason to have a new programming language. And so it was this research out of Carnegie Mellon and this idea of resource-oriented programming that was that new paradigm. And I think that it really is the right paradigm for smart contract development, and I think it absolutely warrants a new language, and I think Cadence is a great manifestation of those ideas. It's kind of amazing to sit down and program in Cadence today because, you know, back in 2018 when we first started working on it, it kind of seemed like almost an impossible dream. And now today, you know, I can sit down and have an idea for a smart contract, and what I realize is that I'm spending time thinking about the problem I'm trying to solve and not thinking about the ways in which it could all go wrong. And it's incredibly powerful. And obviously, you know, you still have to do defensive code and check for certain things, but that's like 10% of the time now instead of half the time now. And it's really freeing to be able to just create instead of, you know, with the language as your partner in creation, as opposed to, you know, fighting with the tools, fighting with the language, and like, frankly, being worried that damn reentrancy is going to stab you in the back at some point. Yeah, I don't know. It's just a really joyful experience. Well, you know, it's funny because for a really long time, people wanted us to support the EVM on Flow, and there's very good reasons. Like, there's a ton of code out there, and there's no point in us reinventing every single wheel. And you know, and so we thought really long and hard about how to do it. And the reality is that my conviction is as high as it's ever been, that, and higher even, that Cadence is the future of smart contract development. Introducing EVM to Flow in a way where the two might compete, or where they were like two separate environments, both to developers and users, was it was just a non-starter. And I suppose we could have done that, and it would have been very expedient, and maybe people would have been excited about it. But at the end of the day, the goal for me is to make sure that application developers like myself have the best tools available to them, and figuring out how to take Solidity, which is the best tool for certain things, especially when the code already exists, and integrating that into Flow, not just adding it to Flow. That was the real challenge. And it was, I think, it was a real light bulb moment when one of the engineers working on this problem used the term, and it's going to sound dumb, they used the term virtual machine. And obviously EVM stands for Ethereum Virtual Machine, right? Like, we use that term all the time. But he used the phrase virtual machine. And somehow, like, going back and running Windows in an emulator on my Mac just like flashed into my brain. And it was like so obvious to me that creating an EVM emulator inside Cadence, rather than having an EVM next to Cadence, but having EVM emulation inside Cadence in a way where, to the software running in the emulator, it was perfect emulation. But to the blockchain writ large, it became an embedded part of what already existed with Cadence. It was just so obvious that that was going to be the right integration point that meant that we could get basically perfect EVM equivalents, both for clients and for smart contracts, while at the same time giving developers, whether they start in Cadence or whether they start in EVM, the power of both environments. And what we're seeing now is people who have deployed EVM smart contracts on Flow starting to take a look at how they can use Cadence to improve their product. Now, that might be just as simple as using a Cadence script to query some EVM state, but being able to call multiple functions in the EVM in a single query, because Cadence allows for arbitrary result queries, result queries in scripts. Or it could be as complex as building a whole new feature for their application while continuing to use the code on EVM as a facility to power that. We're seeing tools, and I built some tools myself, that let you interact with DEXs on both sides transparently from inside Cadence. And you can just say, I want to swap, and it'll check the Cadence DEX, and if it has a swap, it'll do it, and it'll check the EVM DEX, and if it has a swap, it'll do it. And it's just an incredibly powerful way to take the existing EVM code and all of the functionality that brings us, while providing a growth path that, I mean, sadly, even Ethereum hasn't figured out. And so I think it's really a powerful place to deploy any kind of smart contract. One of the key value propositions of blockchains in general is that we get rid of gatekeepers and interim agents, and we get creators interacting directly with their users. We get users interacting directly with other users. And so this idea that MEV is just the blockchain equivalent of an agent's fees or an exchange's commission, I just think that's dreaming too small. The whole point of this technology is that we can get rid of those gatekeepers and those tax collectors and interact directly. And so why should we put up with it at the protocol level? And when we have the technology to get rid of it entirely. So one of the key insights that led to the creation of Flow in the first place was this idea that we could separate the problem of consensus from the problem of computation. And when you look at how blockchain networks work, those are sort of the two fundamental operations that they do. And the way that blockchains traditionally have been built, going all the way back to Bitcoin, is just to have a single set of nodes that are doing both of those tasks. But there's actually no reason why they need to be done together. And so, I think Flow was the first, but it's not the only blockchain these days that separates those two aspects. And And when you create a block, you don't need to actually run all the transactions. You just collect them together, and then you can execute that set of transactions after the order has been set and the consensus has been declared. And one of the questions that came up then is that, well, how do we collect all those transactions together such that we're creating a mempool that you can build blocks out of? And one of the things that we talked about early on was, well, at the end of the day, we have these powerful computers that we call execution nodes that do the execution. They need a copy of all of the transactions. So why don't we just send the transactions to them, and then we can order the transactions from there, and then we'll have a bunch of, we'll have a large number of computers coming to consensus, and then we can execute the transactions once they've been given an order. But the problem with that is that whoever you send those transactions to first has a tremendous amount of power. They have the ability to suppress transactions, to just simply not include them. They have the ability to reorder them, to delay when they get seen by the rest of the network. And I think most critically, and what we now know of today as MEV, or specifically front-running and sandwich attacks, is that they can take a look at your transaction, see what it's going to do or what it's trying to do, and engage in activity that profits from your action in a way that probably just steals directly from you. The classic sandwich attack, I see you're going to go buy token X, so I put in a transaction ahead of yours that buys some token X, you buy token X pushing up the price a little bit, and then I sell the token at the end. You end up paying an extra $5,000 for your purchase, and I make $5,000. Straight up value transfer from you to me. And we just didn't want to allow that. And so we created a whole separate part of the network that we call the collection nodes to solve this exact problem. And what's interesting is that at the time that we had that idea, that term MEV hadn't even been coined yet. It just seemed obvious that, giving that power to a small number of nodes was potentially very dangerous. And fortunately, over the years, there's been a lot of very sophisticated thought about MEV. And in some cases, people feel like the answer is that, well, if we can control it, if we can tame it, if we can if we can keep the problem small enough, then it doesn't undermine the ultimate value of the blockchain. And that's probably true, but I think that the architecture that we have with Flow, where we're basically taking that mempool and putting it under consensus, means that we largely don't have to think about MEV issues at all. And so this architecture that has just a much larger number of collection nodes than than most other node types means that you have a lot of options for how you submit your transaction, even though everything gets funneled in together and is executed together. But critically, the nodes that are making the decision on whether or not to include your transaction, they don't say anything about the order in which the transactions are executed. The nodes that decide the order that the transactions are going to be executed in, they don't have the ability to insert new transactions into the transaction stream. And the nodes that actually do the execution of the transactions, and therefore, could reliably predict what these transactions are going to do, they can't do either of those things. They can't insert new transactions, nor can they change the order of them. And so by separating those responsibilities out, it means that there's no one actor that has the ability to do anything remotely looking like a sandwich attack. I've spent my whole life wanting to build new things, and the reality is that, and most of my ideas, I could never get funded because people didn't see the vision. And it wasn't until, I was at Axiom Zen where some of these crazy ideas were taken seriously. And of course, obviously, CryptoKitties is the example that really kicked this all off. But I don't know. It's just my whole career is filled with me having these crazy ideas, sort of akin to Flow. And Flow is really the first one that, having just come off some success and having the credibility of success, that enough people were willing to put their energy behind it. So I don't know. I guess it's just kind of who I am. Like I in a weird way, I don't want to be successful. I want to create great things. And obviously, there's ideally a high correlation between those. But it's, to me, it's about meeting the goals that I've set for what we're trying to achieve, or what other people on the team come up with, than it is any sort of external metric of success.